This is your flip lesson for the layers of the Earth. All of the information that you see on the whiteboards behind me is going to go on the foldable that we made on Monday in class. If you weren't here on Monday, don't make the foldable. You will simply put all of this information into your spiral notebook. Everyone else will put it on the foldable itself. Okay? On the foldable, you're going to want to turn the flap down and write on the inside of the flap for that particular layer. So we're going to start with the inner core. And if you look at your foldable, that's that very small piece of pie shape that you have at the bottom. You colored it red. Okay? Here are some characteristics about this layer. And if you cut out those little squares and glued it down, you can write right on that square. If not, just write it on the flap. All right, the composition. What is the inner core made of? It's made of two metals, iron and nickel. All right, which is a composition of another layer as well. Its thickness, it's about 2,400 kilometers thick. That's about 1,500 miles. Now by thickness for this one, we're talking about diameter. How far is it across from one point to the other? The state of matter for the inner core is a solid. All right, it is our hottest layer, and typically you think about, well, the hotter something gets, it changes its state of matter. This should actually be a liquid layer, if not a gas layer. But the inner core is under such extreme heat and pressure. And the more heat and pressure you add to something, it actually becomes a solid. So that's something specific that you're going to need to know, that even though it is very hot, it is a solid state of matter. Now as we move away from the inner core, we go up one layer and we start talking about the outer core. You'll notice the composition of the outer core is the exact same composition as the inner core. It's made of the same two metals, iron and nickel. All right, and they roughly have the same thickness or diameter, just about 1,400 miles. Now for this one, we actually could talk about thickness because it is a surrounding layer if we wanted to. Now the difference between the inner core and outer core, this is a liquid layer. The temperature is hot, not as hot as here, but the heat and pressure is less here as well. Okay, so this outer core layer is actually a liquid layer that surrounds the solid inner core layer. All right, our next layer up, if we go up our picture here, is the mantle. And the mantle is broken up into several different layers. Okay, on yours you had the lower mantle, which was this piece right here closest to the outer core. We have this chunk of the middle mantle, and then we have this upper mantle, and we're going to talk about that. The composition of this is molten, which means melted rock. Okay, so the mantle is a constant heating and cooling of rock. Okay, its thickness, it is our thickest layer. It's about 1,700 miles thick. All right, very dense, thick layer. All right, but it does float on top of the outer core. All right, so the density, depending on where you are, does get smaller as you go down the mantle. Okay, now the state of matter, it's not just one state of matter. It actually fluctuates depending on where you are in the mantle. If I'm up here at the top of the mantle, closest to the crust, I'm going to find solid rock there. As I move away from the crust, the temperature is going to increase. This is a semi-solid, almost like tar or a thick paste type consistency. And then this is going to be more liquid-like in this section that's not colored in. Okay? So, and all of this is based on temperature. As you go closer to the outer core, the temperature increases, which means things are going to melt and turn into a more liquid-like layer. In the mantle, and that should say mantle right there, it got smudged when I moved the boards. All right, in the mantle, there are convection currents. So you see I've represented that here with the blue and the red. You've seen this before with energy transfer. We talked about convection. Convection happens in two places, liquids and solids. Liquids and gases. All right, the mantle is a semi-liquid state, so that's where convection takes place. As you move closer to the crust, I made them blue because that represents a cold temperature. As you move down into the mantle here towards the outer core, those become red. All right, so in these convection currents, I have solid rock up here. It's heavy, it's more dense, so it starts to sink down into the liquid layers. Well, what happens when it gets down here? The temperature increases, it liquefies. Once it liquefies, it gets pushed back up here to where it cools. Then it gets heavy, it sinks. It cools, it sinks, it cools. And that's what I have represented here. The solid rock is going to sink towards the outer core and it melts. Okay, it sinks down towards here and it melts. Once it melts, it becomes less dense. All right, it's liquid, so it's going to get pushed up here. Once it gets up here because it's being pushed out of the way, it cools. It sinks, it melts. It cools. It sinks, it melts. It cools. And these currents are continuous. It's this rising and falling of rock that is being heated to the point where it melts. It rises to the top of the mantle, it cools, and this process goes on and goes on. Now we're going to talk about what these convection currents do for us here on our planet. They are very noticeable to us here on the surface of the Earth. All right, our last layer, it's the outermost layer, is the crust. All right, and so we're building on top of those layers. Now on your foldable, you had the ocean on one side, which I badly represented here, and then you had land on the other side. The composition is rock. It is solid rock. Its thickness varies depending on where you are. If I'm underneath the ocean water, all right, over here on this side, it's very thin, only about 3 miles thick. But if I'm underneath a continent, they can go upwards of 45 miles thick. All right, so there are two different kinds of crust. One is the oceanic crust and one is continental. The difference is one is under the ocean floor, one is not. Okay, the state of matter, the crust is completely solid. Now some of you are thinking, well, the ocean water is a liquid. We're not talking about the ocean water, we're talking about the rock that is at the bottom of the ocean floor. Okay? The crust in the upper part of the mantle is called the lithosphere. So this crust layer plus the very tippy top of the mantle, right, is called the lithosphere, and it sort of floats on top of this red layer, which is called the asthenosphere, and it's like a thick glue. Okay, so the lithosphere is floating, and it's actually broken up into pieces. This lithosphere is cracked into many pieces, and they float on top of the asthenosphere, which is like this thick paste-like material. And we're going to talk about what happens when this floating gets out of control and things like that. So make sure you have all of these for the layers of the Earth. Now what you're going to do is go to my website and you're going to watch the video clip I've posted there about the layers of the Earth.